Hello everyone, I am going to teach question number 6th and question number 7th from exercise 7.3 of class 12, and you know that 7th chapter based on differentiation. So we will start from question number 6th. Find dy over dx of following functions. So here we have two parts, part A and part B. So we will start by part A. In part A, y equal to x to the power y is given to us, and from here we have to find out dy over dx. So I assume this as equation 1. Now because it's a implicit function means in which the variables we cannot separate. That's why we'll take log in both the sides. So when we'll take log on both the sides, it's going to be log y is equal to log x to the power y. Now here I had used the formula log m to the power n is power used to come in front in log. That's why y came here. Now since the variable separated, so now we have to differentiate it. So on differentiating with respect to x, we get, so derivative symbol came here also and here also. Now log y is differentiation. So you know that log x differentiation is 1 upon x. That's why log y differentiation is 1 upon y, and because of the chain rule, derivative symbol came with y. Now here we have two functions, y multiplied by log x. So when two functions are in multiply, this is the formula. In that part, any one function we have to keep as it is, second function we have to differentiate, and then second function we have to keep as it is, and first function we have to differentiate. In the same way here, I kept this y as it is, and derivative symbol came with log x. Then in next time log x I kept as it is, and derivative symbol came with y. Now in next step, in left hand side keep right as it is, and in right hand side when we'll here because in the question we need dy over dx, that's why this term have dy over dx. So this term from right to left I shifted because we cannot differentiate it further. That's why I shifted here. That's why symbol changed. Now here when we differentiate log x differentiation is 1 upon x, and because of the chain rule, derivative symbol came with x. Now dx over dx is 1. That's why y over x. Now here take dy over dx common. After taking common, we are remain with 1 upon y minus log x in the bracket. Now take LCM. After taking LCM, we will obtain this step. Now this fraction is in multiply with dy over dx. So when we shift this fraction in right hand side, we have to do its reciprocal. So when we will do reciprocal, we will get this. And here we can't cancel anything. So multiply y by y. So this is our final answer. So the part A of question number 7 is completed. Now we'll start the part B of same question number 6th. So part B is, you can see the question, x to the power a multiplied by y to the power b is equal to x minus a to the power a plus b. Again you can see that here if we take log, then easily we can solve it. That's why on taking log on both the sides we will get. So here when we took log, we got this equation. Now here they are in multiply, and you know that log m multiplied by n is equal to log m plus log n. Now that's why since they are in multiply, so when we will separate this, plus symbol will come in middle. Now here it is in the form of log m to the power n. So power will come in front. In the same way here also a plus b will come in front. So we will obtain this equation. Now again it is in the power form. So a will come front, and here also b will come front. So we obtain this equation. Now just differentiate it. So on differentiating with respect to x, derivative symbol came with all three terms. Now here since it's a coefficient, a is a coefficient, that's why a just will shift in front. Here also b will shift in front, and here also a plus b is a coefficient, so it will shift in front. Now we will differentiate it, and you know log x differentiation is 1 upon x. That's why log x differentiation is 1 upon x, and because of the chain rule, derivative symbol came with x. In the same way, log y differentiation is 1 upon y and derivative symbol came with y. Here also log x minus y differentiation is 1 upon x minus y. Then because of the chain rule, we have to differentiate this x minus y again. Now in next step, here dx over dx is 1, so 1, and b upon y, and we cannot differentiate it, we want this, that's why keep it as it is. Now here this derivative symbol will distribute to both, and you know x differentiation is 1 and dy over dx as it is. Now open the bracket. When you will open the bracket, this small bracket will distribute over big bracket, so we will obtain this step. Now since we want dy over dx, that's why this dy over dx term just shift in the right side, so positive term will come here, and this a upon x shift in the left side, so minus a upon x came here. Simply we had shifted. Now take dy over dx common here, then take the LCM. Here also take the LCM. After taking LCM and open the bracket, after all the calculations and cancellations, here you can see by and by cancelled, and here you can see ax and ax cancelled. Now what we found is here the numerator is same, so they will cancel, or what I had done is this fraction is in multiply, so it will go in divide. So this and they are same, so it will cancel. X minus y will cancel by x minus y, so we are remained with y upon x. Now sixth question, both the parts completed. So in this both the parts we have took log. Now we will start the question number 7. In question number 7, again we have to find out dy over dx for following functions. So part A is this. So we will start the differentiating them. So derivative symbol came with all, and we want dy over dx that we have here. So simply we will differentiate it. So you know ex differentiation is ex. So this ex differentiation is ex. Now here also e to the power x square differentiation is e to the power x square, but because of chain rule, here again we have to differentiate the x square. In the same way, its differentiation is going to be same, but because of the chain rule we have to differentiate this x cube. In the same here also its differentiation is again same, but because of chain rule we have to differentiate x4. In the same way here also its differentiation is same, and chain rule we have to differentiate x to the power 5. Now this ex as it is. Now when we differentiate it, we are going to use the formula x to the power n, that is n x n minus 1. So here it's x to the power 2, so n is 2, so 2x 2 minus 1, and here n is 3, so 3x 3 minus 1 is 2. In the same way 4x 4 minus 1 is x cube. Then when we differentiate it, 5x 5 minus 1, that is 4. So we had used the formula to differentiate all these terms. We had used the formula x to the power n differentiation, that is n x n minus 1, and that's our answer of this part A of question number 7. Now we'll start by part B. In part B, question is given like this. So I assume it as y because we need to find out dy over dx. Now since we have to differentiate it, that's why this root I wrote as power form, so that I can use the formula x to the power n, that is n x n minus 1. So here we'll assume this as x, so half will behave as power, that is n x n minus 1, but it's not x, that's why we have to use the chain rule. That's why derivative symbol became with e to the power root x. Now in next step, when we subtract it, we'll get here minus half, these terms as it is. Now its differentiation, you know e to the power x differentiation is e to the power x only, that's why e to the power root x differentiation is also e to the power root x, but since it's not x, that's why we have to use the chain rule. So we'll differentiate this root x again. Now root x means we can write it as half, so half x to the power half, so when we differentiate we'll get n x n minus 1, and remaining terms here, this term as it is, this half as it is. Since we have minus half here, because of minus sign it came in the denominator, and because of half again root came here. So I hope this step is clear to you. Because of minus it came in denominator, and because of this half, this outside root symbol came. This term as it is, and here I differentiated with the help of n x n minus 1. Now half minus 1 is minus half, so x to the power minus half is 1 upon root x. So this 2 and 2 becomes 4 here, In numerator this will multiply by 1, so we will get e to the power root x, and this is minus half, that's why it will come in the denominator with root symbol, that's why we got here root x. Now since here also root and here also root, so they will come in the same root symbol, that's why we obtained this step. Hence question number 6 and 7 completed. So students, in question number 6, in first part we got implicit function, that's why we took the log, and in second again we had power form of variables, that's why in 6th question in both the parts we took log, but in 7th question directly we had used the differentiation formula and we used the chain rule. Thank you.